let's start introducing you guys to soils. I got a couple quotes up there. There's a whole boatload of quotes. If you really want to have some great quotes, go to this website down here. I'll write it down later if you want it. But basically, we're going to be talking about soils. No big surprise there. But coming from a lot of different people and from a lot of different perspectives and a lot of different eras, soils have been felt or considered to be pretty darn important. Okay? Now, that's not my plug to say you should be in this class, but it's my plug to say, hey, we're not the only people that recognize that this is important. So let's talk about what soil is. I suspect that a lot of you guys came into this class with some expectation of what soil is. Okay? Generally, most people, when they think of soil or dirt, they think of a thing. You know, some kind of hard thing I can touch. I want you guys to think of soil from a different perspective. I don't want you to think of soil as a thing. I want you to think of soil as a volume. Okay? Because soil is not just made up of organisms and rocks and organic matter, or minerals and organic matter. It's also made up of water and air. And when you start thinking about water and air, you have to start thinking about a dynamic system. It rains, what happens to your soil volume? What happens to it? It rains. It fills up with water. So if it fills up with water, what happens to the air? It what? Say it again. It's less air. Where does that air go, though? Well, sometimes it can be pressurized. Most of the time when the water goes in, the air comes out. Or it goes as a front end of a leading, the waterfront. Water's pushing this way, you have forced air coming throughout. Has anybody gone into, this is not quite the right analogy, but has anybody gone into a cave and you feel the breeze coming out? Okay, well, why is that breeze coming out? Air is rising in one location and it's creating a sort of a suction or a pressure. The same thing's happening with the caves that are the particles between soils. Things are pushing in, things are going to push out. Okay, so we've got actually a pretty good handle on what soil is already. Maybe not technically, but we have an idea. Okay, it's not just the stuff that you walk on. It's not just the stuff that grass grows in. Okay? Soil is a volume. Okay? And the coolest thing about soil is that soil is at the interface of 4 very important realms of the planet. The first one is the atmosphere. Okay, obviously, if I'm standing up here and this is the soil below me, there's an interface between the atmosphere and that material below me. But if soil is actually a volume of which it's not a solid material, that atmosphere is interacting all the way down through that soil. It's not just at the surface. Okay? All right. It is also the interface between the lithosphere, the rocks. Okay? It is the interface between up here and the bedrock down there. Does that make sense? Okay? Things happen at the exchange sites. The exciting part of ecology and systematics is at the edge. Has anybody ever heard the edge effect? Edge effect? Does that sound familiar? Okay, it's what's happening at the edge. Okay, and soils is the edge. Okay, it's also the interface between the hydrosphere. We just talked about the rain. Okay, it's not just the rain, it's groundwater, it's the oceans, it's the rivers, it's that interface, it's the dew. It's the interface between all of this, and it's the interface to the biosphere. I'm sure all of you guys have sort of heard, even though he never actually said this, but there are millions and billions of stars in the galaxies. He never actually said that. Does anybody know who I'm talking about? Carl Sagan. Okay. Well, it turns out that there are, in fact, millions and millions of organisms underneath our feet. There are more organisms underneath our feet than above it. Okay, the tablespoon of soil that has 1 million organisms in it is legitimate, though it is somewhat selective. You've got to take a certain type of soil to do that, but it really is there. So it really is the interface. Soil sits in this Venn diagram between these 4 very important realms of our planet. Okay, and it's a volume. It's not just a thin skin. It's a volume. Okay, so let's talk about that volume. Well, there are basically 4 components to that soil volume. Okay? The first, and the one that most people think of, is this mineral component. Okay? Basically 45%, and about 5% of it is organic, living and dead. So in an idealized soil, this is that circle, 50% of that soil volume is actually solid material. 45% of the total is mineral, 5% is organic. The other 50% is air in solution, or you can call it water. Okay? Now, very easy to say this is 45 and this is 5. It basically is. Okay? It's not so easy to do this. It's not so easy to say 25% is air and 25% is solution. Because what happens when it rains? Well, that solution component is going to get a lot larger. And we're going to lose the air. Give it a couple days, the water drains out, the plants start respiring, they start sucking up that water, and all of a sudden this solution starts getting down here. And as we're having much part of the country right now, and we had in Ithaca for a significant part of the summer, you can get this so far down that you go into drought conditions. So this half is very dynamic, very, very dynamic. It turns out that this side is actually fairly dynamic as well. This organic material, all over the place. Depending upon how you're managing, depending upon what type of organisms are living in the environment that that soil is located, this organic matter can be as high as 100%, or 50% I should say, to as low as 0. This organic section, and throughout this entire volume, we also have biota. This is that comment that we made earlier, that soils are also organisms. This is microorganisms, macrofauna, as well as plants. Okay? Very large community of biota, large variation in this, and huge variation dynamics in the water and air, or soil solution in air. Okay, questions so far? So let's get to the technical end. What is the I already threw this out there. What do you think of as soil? Well, there are a couple of technical concepts, technical definitions. There's a geologic definition as well as sort of a traditional definition. Geological definition is basically loose surface material between the boundary layer of here and the boundary layer of rocks. This loose material. There's no requirements on it. It's just loose material. Okay? Traditional, it's this loose altered surface material of the surface that in some cases, and in this case, includes rocks, water, snow, air, etc., but is capable of growing plants. Those are sort of the 2 definitions that most people operate by. Us being soil scientists, scientists being the operative word, we have our own real definition of what soil is, but basically it subsumes these 2 ideas. This loose material encompasses rocks, air, and water, and is capable of supplying nutrients and growing plants. Okay? Our definition is a little bit longer, a little bit cooler. We're soil scientists. Basically, it's saying this loose material has been modified over time. Okay? The difference between soil and dirt, right? Because it's been modified. We've had that little conversation already, right? Okay? It's also characterized by one or more of the following. This modification has produced layers, distinctive characteristics changing through that soil profile, or it contains living material, or is capable of. Finally, there's an upper limit. That upper limit is air, shallow water, live plants, or loose plant material that has not yet begun to decompose, i.e. wood chips. The lower limit is the depth to which that weathering, that alteration has occurred. Okay? In some cases, this is hard rock. In some cases, this is not that far down, but it's basically sitting on top of a pile of sand or something like that. Does that make sense to everybody? But it encompasses these 2 traditional views that most people sort of think of as soil. Okay, questions so far? So I have sort of introduced this idea a couple times, but soil versus dirt, soil undergoes some sort of alteration that produces soil. So let me introduce those alteration processes. What are they? Now you guys, I think, without even looking at this, I think you guys could come up with all of these. Okay, what are the things that you think that happen in the real world that could potentially alter some material in it? First one is things can be added to it, right? You got a landslide, you have a wind event, you have a flood, stuff comes in, dust comes in from the air, things get brought in by water, okay? That is an alteration process. I have material here and something comes in and alters it by adding, okay? Those same processes could also remove. So we also could have additions, but we also could have losses. Does that make sense? Now, the one thing to think about when you talk about additions and losses, most people when we think of additions and losses, we're talking about the surfaces. Okay? A windstorm deposits stuff right on top. But the truth is you can have additions and losses coming in from below because you have water coming in from below. If the water has something entrained in it or dissolved in it, that material can be put into the soil. Does that make sense? It also can leach stuff away. If the water comes through a material and leaves that material as groundwater, it's going to potentially dissolve materials that are in that media and take it away. Okay, so it's not just on the top, it's throughout that whole volume of material. Okay? Now, if I have water moving into the system or I have heat transfer, I mean sunlight comes down, I can also have alterations. The material doesn't move, but it changes in space. Okay? I'm sure most of you guys have taken chemistry. Okay? If you put a solution in with another thing, you mix it up, you can potentially make something else, right? Has anybody made rock candy? Well, real simple. Okay? You put sugar into boiling water, and you put a string in it, and you basically let it cool and let the sugar crystallize. It's still sugar, but it has altered its form. Well, that kind of stuff happens. That's an alteration. Okay? That kind of stuff happens in soils. We have crystals forming all the time. They may not be sugar, so I'm not suggesting that you go out there and eat dirt, but it's an alteration. It's cool. All right. Last one is a translocation. Translocation just means move. Okay? You can certainly imagine if it rains up here, that water potentially can entrain something or carry something in it and move it down into the soil and move it to a new location. In fact, next week, the first soil that you guys are going to see is a classic example of this entrainment. Rainwater hits the ground, entrains or puts into the water column very small clay particles. Those clay particles move through sand and get deposited farther down. That's a translocation. Does that make sense? Okay, go. That is within the same volume. Okay, so if I have clay that's at the top and it's being moved down into the same volume versus clay coming in or nutrients coming in from water into that same volume. Okay, now that actually brings up an interesting question. What is your definition of the boundary? You know, my volume is here, but if it's a little bit larger, the water actually may be coming from the same condition. And we will actually talk about that because part of this course is about how these soils vary across the landscape, how the landscape modifies that soil. And that is a very appropriate question for that. Okay, one other thing. We're still on translocation. Has anybody walked through the tunnel between plant science and man library? We do it all the time when we're going to mandibles or something like that. Has anybody ever, now this is the part that may be tough, has anybody ever actually looked at the walls? Has anybody ever noticed that there are salt stains on those walls? If you haven't, go in there and take a look. Walk down that hallway, and there's a little bit on the left and a little bit on the right if you're coming from this direction. There's salt stains on the walls. And basically what that is coming from wicking. Water is coming in, moving down. I mean, it rains, it snows. You guys have been in Ithaca a while. You know what happens. Okay? Water hits the ground. It moves along the surface, and then it hits the surface walls and basically starts moving up. Okay, capillary action, wicking, right? You guys saw this happen when you were kids with straws. Okay, you put a straw in water, and what happens when you pull it out? There's a little drop of water on the end, right? Okay? Well, what's happening is that water is in training dissolving salts. There's a lot of salt around here. Every time it snows, what does Cornell do to the sidewalks? Covers it with salt, right? Well, the water that comes in there that dissolves solubilizes that salt, puts it in the water. That water then runs in, down the tunnel, hits those walls, and starts climbing the walls because of capillary action. Well, sooner or later, that water is going to evaporate. And what's left behind? The salt. Well, the same thing happens in soils. Around here, it's not a big deal. But what happens if you're out in the west or in the deserts? One good rainstorm solubilizes all the salts. Water moves into the soil, but doesn't make it all the way down. Actually starts coming back up because of evapotranspiration. It goes down, it solubilizes all the salts, comes back up, evaporates, and leaves the salts behind. Does that make sense? I will be showing you some pictures of this later in the semester. This is one of the really cool things about this translocation. Translocation doesn't just necessarily go down, but it also potentially goes up. Okay, cool? Questions?
This has been a production of Cornell University, on the web at cornell.edu.